All right, we're moving on to section 4.3. We have talked a bit about what a proof is, but I'm going to start working you into the concept of more abstract math where you're proving things in infinitely many cases. So in 4.3, it says yesterday made a conjecture about the relationship between the two remote interior angles and the corresponding exterior angles. We're going to use this to help us develop a path to a proof. So it says use a tool from our toolbox to determine what the value of measure of angle 4 is. So when you're looking at this, the tool that you would have used is you would have used linear pairs or supplementary. So that would be your justification, and you would know that that was 50 degrees. Now the next one, same deal. Linear pairs or supplementary we could use, and we could find out that a measure of angle 4 equals 125 degrees. So it is important for us to be able to say what we know and then how we knew it, like what was the tool that we used. So in both those, we used the tool, linear pairs or supplementary, to find out the unknown. The next one, once again, it says what tool allowed you to determine measure of angle 4? That'd be linear pairs are supplementary. Now the next one is where we start getting into abstract concepts and writing things out in infinitely many cases. So it says, well, you cannot determine the exact value of measure of angle 4. You can write an expression that describes the measure of angle 4. What is the expression? Hint, think about how you did the last problem. Well, we knew we did the last problem by just taking 180 and taking away that angle that was on the interior, and then that told me what was on the exterior. So the measure of angle 4 is just going to equal 180 minus x, because we have just described that as x degrees. Once again, the reason we're doing this is just to make sure that you guys understand the concept of how you can go over and write out an expression looking at infinitely many cases. So since x does not have a exact value, this is infinitely many cases we're looking at here. 4 would just be 180 minus that value of x. Or if we went over and named that angle 5, it would be 180 minus measure of angle 5. The next one says, use the diagram to the right to finish the statements. Note how you knew each one of the pieces of information. So we have 1, 2, and 3 are going to equal how many degrees? 180, because of the triangle angle sum theorem. Great. The next one is that 1 and 4 equal 180, and that's because linear pairs are supplementary. Now we have 1 plus 2 plus 3 equals 180, all of those measures, and 1 and 4 equals 180. Then we're able to say that 1 plus 2 plus 3 equals 1 plus 4. What can we do with this? So the way that we did that was, since we knew that 180 equaled something, you can erase 180 and you can put in what 180 equals. That's called substitution. So we did substitution here, and we ended up getting 1 plus 2 plus 3 equals 1 plus 4. Now just looking at this, what could we do? Well, we can see that you have measure of angle 1 on both sides. So I could subtract measure of angle 1 from the left and from the right, and you're ending up with 2 plus 3 equals the 4. Measure of 2 plus measure of 3 equals measure of 4. Now the cool thing with this is we didn't look at a single case or 10 cases or 100 cases. This is proving it in infinitely many cases. So this is the concept of don't define the exact number of degrees, because now you're linking it to a single example. If we just talk about it as the measure of angle 3, then that could be any value, and we're looking at all cases. So we have just proved the remote interior angles theorem in all cases. Now, with that said, you had to have already known the triangle angle sum theorem to be able to do that. Now, your quick notes are as follows. Proofs use a logical progression looking at abstract cases, naming angles rather than using exact measures. You will have statements and reasons. So in a box, you'll have a statement, and then underneath it, you can write down what the reason was. You could also organize this into something called a two-column proof, but we'll be looking at that later. So the next one says, now we're going to use the remote interior angles theorem to prove that the sum of the interior angles is 180 degrees. We are assuming we know that the exterior angles theorem works. So when we're looking at this, you have 2 plus 3. 2 plus 3 is going to equal 4, the measure of angle 4. And the way we knew that was the remote interior angles theorem. The next one is measure of angle 1 plus measure of angle 4 equals 180. How did we know that? Well, linear pairs are supplementary. Now, if we had this, then we can go over and say, I'm going to subtract away the measure of angle 1 from the left and from the right. So what did you do? You subtracted measure of angle 1 from both sides. There's a technical name for that, and the name is the subtraction property of equality. It just says you can subtract anything you want from the left as long as you do it to the right. If you add same thing left and right, multiply same thing left to right, or divide same thing left to right, that is that property of equality. So while I just wrote out I subtract measure of angle 1, that's what the kids would probably write, but really it should be subtraction property of equality. Now that you have that, you know that one thing equals measure of angle 4, the other thing equals measure of angle 4. So what we're going to do here, a lot of times if two things equal the same thing, you can set them equal to one another. So since 180 minus measure of 1 is angle 4, and 2 and 3 equal measure of 4, I'm going to set those equal to one another. And I get 2 plus 3 equals 180 minus measure of angle 1. How did I do that? I said I put in what measure of angle 4 is equal to. That's what the students would say. The real name for that is called substitution. You're substituting in a value that you knew, or substituting in something that you knew that something else equaled. Substitution. And lastly, why would we ever want to do that? Well, now, if I want the 180 by itself, I can add measure of angle 1 to both sides, and I end up with 1 plus 2 plus 3 equals 180. I added measure of angle 1 to both sides. And the technical term for that is the addition property of equality. Would I expect you guys to be able to set this up and conjure it up on your own? No, but you should be able to explain what's going on here. We can justify things using remote interior angles theorem, linear pairs or subtraction property of equality, substitution, multiplication property of equality. All these things are justifications for why we're able to do certain things. Now, next one, try to come up with a logical argument using corresponding angles theorem, alternate interior angles theorem, same side interior angles theorem, and alternate exterior angles, and linear pairs are supplementary to show that 5 and 2 are supplementary. When you're looking at 5 and 2, they look supplementary, but we don't have like a rule like SSIA or something like that. So there's many different ways to do this, but one of the ways is you could say 5 and 4 are congruent because of AIA, 2 and 4 are sup because of linear pairs, and since you know 4 equals 2, where there was a 4, you put in a 2. So instead of 5 is congruent to 4, you would go over, since 5 is congruent to 4, where there was a 4, you are going to put a 5. Sorry, I messed up when I was talking. We're substituting in a 5 for a 4. The other one I accidentally said 4 was congruent to 2, but 4 is not congruent to 2. 4 and 2 are supplementary. So once again, since 5 is congruent to 4 and I have 4 and 2 are supplementary, then I could erase the 4 and put in a 5, and now 5 and 2 are supplementary. So I was able to justify everything. I justified it by AIA theorem, linear pairs are supplementary, and then the last one is I put in what 4 equals, which is called substitution. Okay. So this is just a logical progression. I'm trying to get you guys to use math and logic to be able to prove things. Now let's look at the homework. It says notation practice. Use the diagram to the right to answer. Write an equation using the correct notation showing that the sum of the interior angles equals 180. So that'd be measure of 1 plus measure of 2 plus measure of 3 equals 180. Just using the abstract concept rather than adding up actual numbers for the number of degrees. Next one, linear pairs add to be 180. That would be measure of angle 3 plus measure of angle 4 equals 180. We're not doing anything with it. I just wanted to see if you guys could set it up. The remote interior angles add to be the measure of the corresponding exterior. So that'd be measure of 1 plus measure of 2 equals measure of 4. On this one, you're supposed to be looking at these diagrams and justifying why we're able to do this. We're not actually doing a proof, we're just justifying it. Well, 5 and 4 are alternate interior angles, so I could say AIA theorem. 9 and 11 are vertical angles, so I could say vertical angles theorem. 5 and 3 are supplementary. When you look at 5 and 3, those are SSIAs, so it'd be SSIA theorem. 5 and 6 are supplementary. If you look at 5 and 6, they're linear pairs, so it'd be linear pairs are supplementary. And then 1 and 4 are vertical angles again. On here, it says we're going to prove that vertical angles theorem. In this problem, you cannot justify anything using vertical angles theorem because that's what we're trying to prove. Later on, you can use vertical angles theorem as much as you want. So they say 9 and 10 add to be how many degrees? 180 degrees. And that's because linear pairs are supplementary. 11 and 10 are also 180 degrees because linear pairs are supplementary. If you have two things that equal 180, then they must equal one another. So it'd be 9 plus 10 equals 11 plus 10. Why would I ever want to do that? Well, look at the left and look at the right. They have something in common. They both have that measure of angle 10 and measure of angle 10. So when you go over and you subtract measure of angle 10 from one side, you do it to the other side, and you're ending up with measure of 9 is equal to measure of 11. And then technically there could be one more step to say they are congruent. So that was, I subtracted measure of angle 10 on both sides, also known as subtraction property of equality. You are supposed to come up with a way of showing that 1 and 7 are supplementary. When you look at 1 and 7, they're supplementary. There's many different ways to do this. I said that 1 and 5 were congruent because of corresponding angles theorem. 5 and 7 are linear pairs. They are supplementary. And then where there was a 5, I put in a 1 by substitution, and I was able to say 1 and 7 are supplementary. That is by substitution. Okay. Hopefully this made sense. We're just kind of looking into the abstract world of geometry and looking at proofs. Rather than using exact numbers, we're just calling it measure of angle 3, measure of angle 2, and just working with this. Thanks for watching.